Lesson 7-7. Our learning target today says I can identify geometric sequences as nonlinear functions. Our essential question is, how do you make a table and a graph for a geometric sequence? So remember that a geometric sequence is a sequence of numbers with a common ratio from one term to the next, meaning that they're being multiplied by the same thing over and over. So our first problem says the NCAA women's basketball tourney begins with 64 teams. In each round, 1/2 of the teams are left to compete until only one team remains. So my starting amount is 64 teams, and I'm reading that 1/2 of the teams are left to compete after each round. Draw a graph to represent how many teams are left in each round, then make a table and write an equation to represent the situation. So we need a graph, table, and equation. So if I start with my graph, there were 64 teams at the beginning, and in each round, 1/2 of the teams are left to compete. So I'm going to call my graph NCAA Women's Basketball Tourney. And we're talking about the number of rounds and how many teams are remaining. Okay, so I have rounds 1, 2, 3, 4, 5, 6, 7, and teams. I'm going by 8 because since there were 64 teams in the tournament, I feel like it's important to show exactly 64 on my graph. So if I go by 8s, I will reach exactly 64. So that someone looking at the graph would not be estimating. Like if I went by 10s, they would see the dot placed between 60 and 70, and they might not know that that was actually 64 teams. So I feel like that's important information in the context of this problem. So I'm going by 8s. So now I have 64 teams to start. And if 50% of them, 1/2 are remaining, that's 50%. Oh, wait a minute. I don't really want my dot right there, I guess. I want it to be first round. So first round, 64 teams. Second round, 32. Third round, 16. Fourth round, 8. And then 4, 2, 1 team remaining. So here's my exponential graph. So this is exponential decay. And the next thing I'm going to do is I'm going to write my equation. So for my equation, I started with f of x equals, so f of x equals, my starting amount of teams was 64, and I was multiplying by 1/2 each time. So 64 times 1/2 to the power of x. And then I'll fit my table over here. So for my table, I'm just going to take the values from my graph, and I could put the labels rounds and teams, or I can just go with x and y. So after round 1, there were 64, or at the beginning of round 1, sorry. Beginning of round 2, 32, 3, 16, 4, 8, 5, 4, 6, 2, and then 7. You know, there isn't really a 7th round. There's only one team remaining, but they're the champion. Okay. Next problem. This is a science experiment kind of a problem. A tennis ball is dropped from a height of 12 feet. Each time the ball bounces back to 80% of the height. So each time the ball bounces, it goes back to 80% of the height from which it fell. Draw a graph to represent the height of the ball after each bounce. Then make a table and write an equation to represent the situation. I'm actually going to start with an equation this time. It really doesn't matter what order you do these in. My equation is going to be f of x equals, it's starting at 12 feet. And if it is bouncing back to 80% of the height from which it fell, 80% as a decimal is 0.8. So I will be multiplying by 0.8 each time. So here's my equation. Now I'm going to make a table next, and then I'll do the graph last this time. So my table, I'm going to just go with 0, 1, 2, 3, and 4. 5 values should be good enough for me to see the curve in this graph. And you can choose if you want to go by 1s, by 2s, by 5s, whatever scale you want. So now I'm just going to calculate. So I've got 12 times 0.8 to the power of 0. Well, that's just 12. Then 12 times 0.8 to the first power is 9.6. If I change it to the second power, I get 7.68. The third power, 6.144. And you can certainly round these numbers. I'll round them after I'm done. And then my last one, the fourth power, 4.9152. So I'm going to round these to the nearest tenth. So this will turn into 7.7, and then this is 6.1 and 4.9. All right, now we're ready for the graph. So the title of my graph, I'm going to call this one Tennis Ball Bounce or Tennis Ball Drop. So I've got height of the tennis ball, and I've got the number of bounces. So height and bounce. Okay. So I can do 0, 1, 2, 3, 4 for my bounce number. And then height, because it started at 12, I'll just go by 2s. So my starting height was 12. After one bounce, it was 9.6. After 2, it was 7.7. After 3, 6.1. And after 4, 4.9. Okay. So curves like that. So we've got our equation, table, graph, everything labeled, done. The last problem is talking about a 50-pound ice sculpture that is melting at a rate in which 90% of its weight remains each hour. So this is very similar to the last problem. So I'll start with an equation. So 90% is remaining. So 90% as a decimal is 0.9, because you move your decimal point 2 places. Remember, it starts here and you go back 2. So my equation would be f of x equals, it started at 50 pounds. It's multiplied by 0.9 because 90% remains. So f of x equals 50 times 0.9 to the power of x. Now I'm going to make my table and then last do my graph again, because I'm not sure what's going to happen with these values. Now in this table, I think I'll change it a little bit. I think I'll go with 0 and then maybe 5, 10, 15, 20 for my melting. So it's starting out at 50 pounds. Now if I put in 5, 50 times 0.9 to the power of 5 is 29.5. I'm going to round this right away. Now if I change this to 10, I get 17.4. Change it to 15, 10.3, and then change it to 20, 6.1. So it's melted quite a bit. So I was trying to figure out how long it was going to last. I got close. Okay, so I'm going to call this, let's see, we've got our equation table, so we need our graph. I'm going to call this ice sculpture melting. So melting ice sculpture. And we're analyzing, see, it said to represent how many pounds of the sculpture are left at each hour. Okay, so I need time in hours. And then how much is left, and it says the weight. So it's the weight in pounds. So I am going to go with, on my x-axis, I went by 5s. And on my y-axis, I'll go by 10s. And I think I'll put a little mark in between at the halfway point to guide me when I'm drawing my graph. Okay, so at time 0, there was 50. Then after 5, it was 29.5. Then after 10, it was 17.4. After 15, it was 10.3. And then 6.1 after 20. Okay. There's my curve. All right. So hopefully this helps you piece together how you can work with a geometric sequence or an exponential equation and connect that equation to a table and a graph.